Welcome back, chemistry fans. Today, what we are going to do is our second homework. This is the last homework you will have to do for this course. This is dealing with calculating the voltage from some battery that we've got. So let's jump right into it. Let me share my screen with you, and then we can get started. Us to calculate what is the voltage if we were able to make this into some kind of a battery. Okay, so now generally speaking, the first element listed is probably your anode, but we can't trust that. So we have to go and look this up. So we'd have to break this into half reactions. We'd have to look at this and see that we have mercury +2 producing some mercury elemental, or +2 as its diatomic here, and its polyatomic ion stage. Okay, and then the other one would be the golds, and it would be as a solid, and it would be as a solid, not as a solid, and it would be producing some gold that is ions. Okay, so now I can go and I can Google this, and my sharing of the screen here should show you that you just Google these values and they will tell you what they are. So here it is down here. It's not too challenging if you want to try and do that, or the more recommended path is to reference what I have given to you now, a laminated sheet of the standard reduction potentials. As I am looking them up right now, let's see, I am finding mercury into diatomic mercury. And let's see, I have got 0.79, but they have it reversed, so it's going to be negative 0.79. And then my gold is going to be and here it is, gold. And again, it's reversed, so it's going to be negative 1.5 is how they've got it. Okay. All right, so now I've got my two voltages. Both of them are negative. You start with the larger value. This one is going to be the anode. This one then would be my cathode. Whichever one has the larger negative value, that means it is the one that is going to give away its energy. So it starts the anode process to the cathode that doesn't give away as much electricity. Okay, now to get into the math of this, though, what we would need to see is how we calculate this using the formula. So the electron potential, the voltage, in other words, is going to be reduction minus oxidation. And once we get figured out, well, who is reducing, who is oxidizing? Well, the stronger material, it is going to be the oxidizer. It is the one that is losing its electrons. So in this case, we would have a negative times negative 1.5, and then up in front, the reduction just stays the same. So it's a negative 0.79. So this kind of always ensures that we end up with some positive numbers. So in this case, I've got 1.5 minus 0.79, and that's going to end up being, is that 0.79 also? Oh my gosh, I don't know. 1.5 minus 0.79, 0.71, sorry, 0.71, and it is positive. Okay, so for the final detail of this story, it asks us to determine spontaneity. If we have calculated this correctly, it's telling us that it's spontaneous. If it is a positive value, the way it is written, it is going to be spontaneous. So it is rare that we end up with a scenario where we won't have spontaneity in these batteries, but it can occur. So in this scenario, we have a positive 0.71 volts, and it is spontaneous. This is everything that I wish to share with you. Thank you very much. We'll talk again soon. Farewell. Goodbye.